Or can I maximize the, okay, is it okay, right? Okay, okay, fine. Okay, yesterday we have, in Tuesday session we have discussed about the importance of IP address and mobile IP networking layers, packet delivery through tunneling, and how the handover management is happening. Means from mobile node, from home agent to foreign agent, it roams, right? This handover, how exactly is happening, and location management. Location management is nothing but a agent discovery. Mobile node has to discover in foreign network that foreign agent, and by discovering these foreign agents in the foreign network, it tries to accommodate in the foreign network. That is, we call it as a location management, and parallelly we can call it as a agent discovery. After that, we have seen registration procedure also, how the registration procedure exactly happened in the mobile IP networking. We have seen these concepts. Today we will see about tunneling and reverse tunneling, how it's exactly happening. While packet delivering in tunneling, how encapsulation we have different kinds of encapsulations, how it's happening. While packets tunneling, we will see in today's topic. First, let us discuss about tunneling. Here we can say the mobile node sends packets using its home IP address, and it is roaming in foreign network. The mobile node initially we can consider in the home network. Slowly it roams into the foreign network. Here between home agent and foreign agent, that means that mobile node is traveled into the foreign network. That destination mobile node, between these three components, these tunnels are establishing. Between these three components, these tunnels are establishing, and through these tunnels, by encapsulating the packets at home agent, we are delivering to the foreign agent through tunnels. And at foreign agent, at receiver point, it decapsulates the packet and it will try to read the packet. Once it understood the packet, it will again encapsulate the packet to tunnel to mobile node. Finally, at mobile node, it will decapsulate the packet and it is able to identify the packet. Here, we are using the purely IP encapsulation. Means already packet have IP header. We are hiding that packet header, that packet IP header data with our mobile IP packet header. Means one more IP packet header is adding to the particular IP packet. Means this is called encapsulation. Suppose take one scenario. In one home network, suppose 3 mobile nodes are present. One home agent is present, and this home agent will have the tunnel list to which IP address, to which tunnel ID this packet should be transmitted, and through all over the networks, through internet, the other end, this foreign network is connected. So many foreign agents are there. Foreign agent also will have this table, IP address and tunnel table. When this one of mobile node from home network to foreign network roams, this foreign agent allocates the care of address to that mobile node, and this foreign agent through tunnels, it is in a position to transport the packets to the mobile node. Here we can say we are using corresponding node also. Corresponding node is nothing but Corresponding node is nothing but a one node. It helps to the foreign agents for delivering the packets to the destination mobile node. Like we can say it is also one router which helps to the agents, foreign agents or home agents. We can call this one as a corresponding node. Okay, first we will go deeply about this tunneling, how it's happening exactly and all. Then we will discuss about reverse tunneling also. In tunneling, what are the protocols are present, that thing also we will discuss now itself. Yesterday, we have seen some scenarios, handover scenarios, like while packet delivering from home network to foreign network, what are the handover scenarios present in the mobile IP networking? That concepts we have seen. There are totally many kinds of scenarios are present. Once again, just we will recap the what are the scenarios we have. The first scenario is we can say corresponding node is a fixed node and mobile node is at the home network. Means here we are talking about corresponding node. Corresponding node at home network. Means home agent, corresponding node, mobile node, all are present at the home network. Then how this transmission is happening? In this case, how this transmission packet delivery is happening? Just mobile node will give packets to home agent. Home agent will try to use, if required, the corresponding node and try to transmit the packets through tunnel to foreign agent. That finally, from foreign agent, that destination mobile node in a position to receive the packets. This is one case. And the second case we have like corresponding node is a mobile node. The mobile node is at the home network with home agent, and mobile node is at the home network with the agent with home agent. Means this is the scenario like we have two home agents in the home network, two or more home agents in the home network, and a corresponding node also present in the home network. This source mobile node is transmitting the packets from the home network to the foreign network by using the two home agents. This is one scenario in packet delivery to the foreign agent. Foreign agent through foreign agent, that foreign mobile node we can say, or destination mobile node. And we just discussed other scenario like we have corresponding node and mobile node. Both are at now foreign network. Now how the transmission is happening? Through that mobile node, packets will come to foreign agent. Foreign agent will use the corresponding node. From there, it will try to transmit the packets to the destination mobile node. It's happening in the third case, we can say. Like this, we have other scenario like two foreign agents and two home agents are present, and one corresponding node is present at foreign network. Now, mobile node is also present at the foreign network. Now, mobile node will start the transmitting the packets. It will first receive the foreign agent 1 and try to utilize the service of corresponding node or foreign agent 2, and it will try to transmit the packets to the destination side. Like this, we have many scenarios, exactly 5 scenarios we have while transmitting the packet delivery by managing the handover in mobile IP networking. Now, we just discussed about the tunneling, exactly what is happening inside these components, encapsulation, how it's happening, what are the protocols present, and what are the packets headers we have. These cases now we will discuss. See, when a mobile node visiting a foreign network supported by a foreign agent, then the foreign agent has the care of address of the mobile node. We all know about this one, like mobile node is traveling from home network to foreign network. When it roams into the foreign network, that foreign agent allocates one address. We call it as a care of address of the mobile node. And through tunnel, foreign agent receives the IP packets from home agent. By establishing tunnels between home agent and foreign agent, then only home agent is in a position to transmit the packets to the foreign agent. We can say home agent IP address to the care of address IP at foreign agent. Means from home agent IP address to that care of address of foreign agent. Means home agent to care of address of foreign agent. That is nothing but a mobile node. Home agent, foreign agent first receive the packets from foreign agent. It will goes to the care of address of the mobile node. Like this, through tunnels is happening. We can say exactly tunnel refers to establishing a pipe. Tunnel is nothing but establishing a pipe. Pipe is a system between two connected ends. Tunnel is like a pipe connection. Pipe is establishing the between two endpoints. The data stream is inserted from one end and retrieved from other end in FIFO manner, first in first order manner. Here what is happening, the data we are inserting at one end and we are retrieving that same particular packets at the other end in tunnels. Whatever the first inserted packet, we are retrieving the first that packet in FIFO manner, first in first out. This packet delivery is happening. Packets received at the home agent are transmitted through the tunnels after encapsulation. From mobile node, packets are received by home agent through tunnels. Only it will try to send those packets to the foreign agent. From foreign agent through tunnels, it will send to the mobile node. Like this is happening. Now, what are the protocols we have in encapsulation? Those things we will see. Just we take one real-time example here. Just I will open that particular slide. Here if we see, here we have correspondent node and home agent and foreign agent. This is mobile node present in the foreign network. Means whenever packets are coming to home agent by using the corresponding node, those packets are transmitting to foreign agent. Finally, those through foreign agent, this mobile node is receiving. Like reverse tunneling means whenever that destination mobile node is transmitting the packets, those packets by using foreign agent, it will travel to the home agent, and finally from home agent, it will try to receive the corresponding node. It's a representation for only reverse tunneling. Here forward tunneling means like from home agent to corresponding node to foreign agent it will go. Here it's a representation clearly for reverse tunneling only. Here not explained about the forward tunneling. It's a, we can take this one as a reverse tunneling. Anyway, I will explain reverse tunneling clearly. Now we can say in tunneling what is happening exactly. Mobile node sends packets using its home IP address. Even while the mobile node is roaming on foreign networks, mobile node able to receive packets by using corresponding nodes. Means through IP address only, this mobile node always transmit the packets in the network. When mobile node roams from home network to foreign network, it is in a position to deliver those packets by using the corresponding node. Foreign agent, corresponding nodes, by using those all agents, it is in a position to deliver the packets. Means between these all components, whatever the data paths are establishing, those we are calling it as a tunnels. And data packets addressed to the mobile node are routed to its home network, where home network establishes tunnels with the corresponding node. First, this from mobile node to, from the destination mobile node to, from source mobile node to, the packets will come to the foreign agent. Foreign agent will give packets to the home agent, and home agent, by using the corresponding nodes, it will try to transmit those packets to the particular destination. Means finally we can say those packets are reaching to the care of address of the mobile node. Here we can say tunneling has two primary functionalities. One is encapsulation of data packet to reach the tunnel endpoint. Whenever we are transmitting the packet at a transmitting site, we are encapsulating the packet at a tunnel for transmitting to endpoint, and we are decapsulating that particular packets when the packet is delivered at the endpoint. We can say simply encapsulation and decapsulation are two primary functionalities in tunneling. Now we know what is corresponding node. Mobile node sends packets to a foreign agent which routes them to a final destination through corresponding node. It means foreign agent is sending packets to the final destination through corresponding node. It means corresponding node also is acting as a one router to transfer packets to the final destination. Now we will just see what is reverse tunneling, what is happening in reverse tunneling. In normal tunnel establishment, the tunnel is established from source mobile node, home agent through corresponding nodes to foreign agent, from foreign agent to destination mobile node. Here, what is happening in reverse tunneling? From destination mobile node to, it will establish tunnels to the foreign agent. From foreign agent to tunnels established to home agent. Like this in reverse direction also, we have the tunnels. We can say it's a bidirectional tunnel with reverse tunneling. The reverse tunnel advantage is multicasting. By using bidirectional tunnel method, means from that particular agent we can multicast packets to the multiple mobile nodes. That is the advantage if reverse tunneling is establishing. We can multicast those packets to all the mobile nodes by that particular foreign agent or home agent. This is the advantage if reverse tunneling is established. We will see how this multicast is happening and all. If we go briefly into this multicasting, first we can say a bidirectional tunnel refers to home agent to foreign agent, and reverse tunneling is happening from foreign agent to home agent. Means it's a forward direction from home agent to foreign agent, and a reverse tunneling from foreign agent to home agent. Information is multicast. Information is always multicast to a mobile node when it sets the option for multicast listening. While we are delivering the packets, we have packet header, right? We are encapsulating the actual IP address with the packet data with our mobile IP header. In that, we are having one field like multicasting enabling flag. If we enabling that flag, it comes to know that it mobile node comes to know that it's a multicast data. By enabling that option, we can do this multicast operation. Multicast means a subset of mobile nodes at a time will receive the data. It's all as a group already formed with respect to one IP address. If it delivers only one IP address, those all packets will receive by this particular group of mobile nodes. This is called as a multicasting. We can say what is the advantage of this reverse tunneling. We can talk about what is the advantage of this reverse tunneling. Is it clear up to now? May I know up to now it's clear? You are not facing any problem with audio and video, right? Okay. I continue. And if we talk about reverse tunneling advantage, we can say it's helpful in firewall security also. So in many industries, we will add firewall securities while entering into the network or from network for our own network to other networks. While entering into the packets, we are just enabling into the firewall security. The advantage here we are getting is when a firewall filters the packets assigned to an IP address received from another IP address, it supports for the reverse tunneling. Means from we can say firewall is we are using firewall security we are using in all over the networks. This is because if any new packets from other domain of IP addresses coming into our own network or from our own network while packets are entering into the new networks, in this case we are always checking whether it's going in proper direction or not. This forward tunneling and reverse tunneling is in a position to support with firewall security also. That's the advantage we have. And the next thing is the next point we'll discuss about the next point we'll discuss about the security, how we are establishing the security in the mobile IP networking layer. That is what now we will see. See, nowadays take any kind of network, whether it's a cellular networks or mobile networks or satellite networks, security is very important. Whatever the packets we are delivering, the other third person should not be involved, should not be in a position to see those information. If he sees that information, that he can mishandle that data. This kind of scenarios we are able to see in real time in many scenarios. Means here how we are establishing the security in mobile IP networks. Now we will see step by step in security procedure. Mobile IP IP uses a strong authentication scheme for security purpose. In mobile IP networking, we are always having the authentication and authorization procedures checking. First of all registration messages between a mobile node and home agent are required to contain the mobile home authentication extension. Means we have seen about the registration messages, registration request, and registration reply messages. We have seen previously. While transmitting this registration request and registration reply messages between components, what we are doing by using one security key, two bytes of, we can say 2 bytes of mobile home authentication extension code we are generating. By using actual packet and some parameters in the packets, we are forming the mobile home authentication extension MHAE. That authentication we are forming a transmitting side, and what we are doing this MHAE, this authentication code, we are appending with the packet, and we are sending with the packet to the receiver. At the receiver, what is happening? Whenever receiver receives this packet, it will also try to form its own mobile home authentication extension with its actual data. After it is formed its own mobile home authentication extension, it will try to check with the transmitter mobile home authentication extension. If two are equal, then we can say integrity is successful, that authentication is successful. If we see about integrity, the integrity of the registration messages is protected by the 128-bit key between mobile node and home node. We are using here 128-bit security key to protect the messages integrity-wise. It is between mobile node to home node to foreign agent to destination mobile node. In all the components, we are using this integrity authentication procedure by using this 128-bit shared key. This is the first point in security. And lastly, what we are doing, the calculated value in integrity functionality is appended in this MHAE, nothing but a mobile home authentication extension. The receiver compares the MHAE with the transmitter MHAE for verification of authentication. This is how security is happening in the mobile IP networking. We are transmitting packet from source mobile node to home agent to foreign agent to destination mobile node. While we are transmitting the packet, what we are doing, we are just calculating MHAE, mobile home authentication extension, for authentication verification purpose, and we are appending this data with the actual packet data, and we are transmitting this packet to receiver. Whenever receiver receives the packet, it will try to calculate its own MHAE, mobile home authentication extension, and it will try to compare with the source MHAE. If both are equal, we can say authentication, the integrity functionality is verified. Like this is happening. Here we have two kinds of authentication extensions. From mobile node to foreign agent, while we are deriving, that one we are calling it as a mobile foreign authentication extension. If we are transmitting packets from foreign agent to home agent, that one we are calling it as a foreign home authentication extension. Means mobile home authentication extension, that is we are forming one calculated value based on 128-bit value. Here two kinds of extensions, from mobile to foreign agent and from foreign agent to home agent. Authentication extensions we can say exactly names: mobile node to foreign agent authentication extension, and foreign agent to home agent authentication extension. Two kinds of extensions we have. And next, we discuss about the encapsulation. How this encapsulation is happening. What are the packet headers we have, and what kind of encapsulation techniques we have. These things we will see now. Just give me 2 minutes. What is happening? Packets from home network to foreign network and foreign network to home network. Now we will see encapsulation. While we are doing packet delivery internals, we have to do encapsulation. After receiving those packets at receiver point, we have to do decapsulation. Means all the packets are transmitting in FIFO order only, first in first out only. We are taking those packets and we are decapsulating that mobile IP header, and we are trying to see that actual IP packet, and once again we are encapsulating the packet for delivering to other end. And other end also, at other end also we are trying to decoding. We are decoding the packet and we are transmitting the packet. Like this is happening end-to-end call flow. Now encapsulation, exactly how it's happening, we see now. See, we know about IP address. The internet protocol is a protocol at network layer. It offset network layer, which is used for the transmission over the internet. While transmitting the packets in internet, we are always using the internet protocol, IP protocol. It is designed for use by networks which enable packets featured data communication. Just now I will open the presentation in encapsulation. Yeah. Previously I explained about security, right? Just we will see that security PPT here. See, in mobile IP networking, that security requirements are providing the RFC 1825. First, we have discussed about the integrity functionalities. Any changes to data between sender and receiver can be detected by the receiver. Means in between also, if third party person enters and try to modify some data, also this receiver comes to know that some mismatch happened in the packet transmission. Authentication. I have explained about MHA, this mobile authentication code, mobile home authentication code extensions I have explained. By using those calculations, that value, we are in a position that particular service we are giving to the correct person or not. Service is utilizing by the correct node or not. That is the checking, we are calling it as a authentication. And confidentiality means only sender and receiver can read the data. Third person even he can't see that data, and he can't modify the data. If modified, the third person is able to understand. And that at the time if integrity fails, that connection will lost, and once again that connection will be established, and that transmission whole thing will happen once again. Means like this is happening. Non-repetition. Sender cannot deny sending of data. Means whatever the packets is received in between node, it can't deny to transmit those particular packet to final destination. Traffic analysis automatically happens by using IP addresses, replay protection, and retransmission. Whenever some error codes are present, based on those error codes, it is in a position to retransmit the packets. Here we can say IP header, authentication header is we are forming, and that final UDP TCP packet data is there. IP header is not encrypted. ESP header and encrypted data. This is only encrypted data we have. And this is a security procedure at the time of registration procedure. What in this slide is saying, in the mobile request, registration request and registration reply messages, we are adding that MHE, mobile home authentication extension, and we are trying to protect the those messages with security. That is what here explaining extensions of IP security architecture. Just he is talking about the timestamps, 32-bit timestamps we are using inside that registration request and registration reply messages. If we take that 128-bit security key from home agent, those security key is first is going to the FA, means foreign agent. Then from there it's going to mobile. From there it's generating the MH, that mobile home authentication extension. Like this, foreign agent has a security association with the home agent. Mobile host registers a new binding at the home agent. Mobile host registers a new binding. Home agent answers the new session key for foreign agent and mobile node. Like the main intention is here it says home agent is sharing that 128-bit key with foreign agent. From foreign agent only that mobile home authentication extension we are calculating and we are using in the packet delivery. This is dynamic host configuration protocol. In next session, we will discuss about this dynamic host configuration protocol. Now, how encapsulation is exactly happening in tunneling, we will see that part. Yeah. Now we will discuss about the encapsulation. First of all, the IP is the protocol at a network layer works. This IP is used for the transmitting over the internet, transmitting the packets over the internet. IP is designed for use by networks which enable packet switched data communication. Means this IP address is designed in such a case like to enable the packet delivery over different kinds of networks. IP provisions the transmission of data packets, each packet treated independently in IP. It implies that every packet must contain complete destination addressing, must contain full destination address. We can say here, while we are transmitting the IP packets over the network, we are doing some fragments of the packets. Each and every fragment of packet should have that IP header. Each fragment is acting as a one independent IP packet. Here it's helpful for transmitting those fragments of packets to the final destination through IP header only by C, that destination IP address. Encapsulation in one way, like the IP packet received at the home agent as an IP header and data with a maximum means we are trying to send IP packets to the terminal. That IP packet maximum size we can say 2 power 16 bytes only. More than that we can't transmit through this terminal. That is happening. And here we are encapsulating actual IP header and actual IP data packet with another IP header, with mobile IP header. So that one we can call it as a new IP header is placed over this IP packet. Now the new IP header has the IP address of home agent as the source and the IP address of the foreign agent as the destination. So we are encapsulating actual IP header and the data with a new IP header. In this new IP header, home agent act as a source IP address and the foreign agent act as a destination IP address. Now, if we take in a hierarchy, first new IP header is coming to the picture, then IP packet header, then IP packet data. We can say additional IP header of an IP packet. This is the first encapsulation method. Means we are already having IP header and packet. We are trying to encapsulate that whole thing with the new IP header. In this new IP header, source home agent IP address act as a source address and foreign agent IP address act as a destination IP address. That's why here also we mention like a new IP header with original IP header, original data. It's for this is new data, and outer header, inner header, and original data it contains. Like this is the procedure is happening in encapsulation. Okay, the data encapsulated with the new IP header has fields like means we are forming the new IP header, right? That fields what we have. We will see exactly now. So this is actual IP header. This is the actual payload. We are forming this new IP header. This one we are calling it as a IP in IP encapsulation. It can support the IPv4 version, IPv6 version also. This IP in IP encapsulation is mentioned clearly in RFC 2003. Okay, now we will just discuss about the fields in the new IP header. Just remember, new IP header is nothing but a encapsulated header. Means it contains home agent address as a source IP address and foreign agent address as a destination IP address. Means it's a mobile IP networking header. In new IP header, what are the fields present? 32-bit value of IP version. Means this this IPv4 or IPv6 we are representing in the 32-bit value, that is IP version. And next is length of the IP header. Length of the IP header is the next field. And third field is precedence of the IP packet. That is third. And total packet length. Next it comes total packet length. And next 4-byte value to specify the ID for the packet, flags and fragment offset for the same. For flags and fragment offset we are using the 4-byte value. And packet ID also we are mentioning a packet can be transmitted in fragments. While transmitting that particular fragment in that particular packet in fragments, we are using the same packet ID for those packets also, for those fragments also. A 4-byte and one more 4-byte to specify time to leave and type of protocol and checksum of the header. We know about the checksum. For finding the errors in transmission of data packets. By using this checksum field, we can come to know some errors are found in transmission of the packets by using this calculated checksum value. Here, mainly if we see this header, here IP address of home agent, IP address of home agent is present, care of address is present. Finally, care of address is present, and inside that packet, IP address of corresponding node, IP address of mobile node. Means this corresponding node is sending to the mobile node. This is we are just forming with a new IP address with IP address of HA and care of address. Means it's a foreign agent which allocated address, that one. This is the IP address of corresponding node and IP address of mobile node. Okay, next slide we'll see. This is IP in IP encapsulation. And next one is minimal encapsulation method. This is optional method. We always mainly majority using IP in IP encapsulation only. If we want, we can go with the minimal encapsulation method also. If we see clearly what is corresponding node, home agent creates tunnels with a device. Home agent creates tunnels with a device to tunnel packets to the foreign agent. This particular device calling as corresponding node. See, home agent is creating tunnel with a device to tunnel packets to the foreign agent by using one a particular node. That node we are calling it as a corresponding node. Corresponding node either we can say it is a home agent 2 or same one, or corresponding node either we can say home agent 2. In foreign network, that we can say foreign agent 2. The foreign agent reads the IP header, means that new IP header. The foreign agent reads the new IP header, that encapsulated data, to get the corresponding to get the care of address. By using care of address, foreign agent sends packets to mobile node after decapsulating the new header. Means here at foreign agent level, when receiving the packets, what is happening, we can say like foreign agent receives the packets, it will try to read that new IP header, that encapsulated data. By reading that encapsulated data, it will come to know that care of address. Here we are able to see in previous slide that care of address. It comes to know that care of address. By using this care of address, foreign agent sends packets to the mobile node. By using that care of address, foreign agent will send that particular packets to the particular care of address after decapsulating the new header. By decapsulating this new header also, it will comes to the care of address and the IP address of mobile node, and it will try to send that particular packet to the mobile node. Next method is minimal encapsulation method. Means it's a we can say it's an optional encapsulation method. We are always going with IP in IP encapsulation only. Minimal encapsulation means some minimal fields only we are encapsulating. That is what happening. Anyway, now we will see about minimal encapsulation by IP header to an IP packet. In minimal encapsulation, what is happening? It will avoid the repetition of identical fields like TTL, IHL, version, TOS. Means we are continuously transmitting the packets, right? In new IP header, we are having some repeated fields, TTL, IHL, version, TOS. It will try to avoid to transmit continuously that redundant data. Only applicable for unfragmented packets. No space left for fragment identification. Means while unfragmented package time, it will try to send these messages. Remaining time, it will try to avoid those redundant data. By avoiding this redundant data, the remain whole header, new IP header is same for transmitting the packet in minimal encapsulation also. The foreign agent transmits the package to the mobile node using the care of address. We know that it's always by decapsulate that new IP header, it will try to get the care of address. By using that care of address, inside of IP address, it will get the mobile node IP address. It will correlate those two things, and foreign agent will try to send those packets to the mobile node finally. And we also have third mechanism in encapsulating the data, that is generic routing encapsulation, GRE. We can say generic routing encapsulation by IP header. Here also we are forming new IP header with the actual IP header and packet. In minimal header, what is happening? In minimal header, if we say clearly what is happening, new IP header we are forming without redundant data in the header, and minimal header. So that is minimal header, and actual IP packet data means actual IP header is there and data is there. Like this is happening in the minimal encapsulation method. Now we will see about the generic routing encapsulation, GRE encapsulation by IP header for the IP packet. Just give me 2 minutes, I will back. Hello. So shall we? Continue. Sorry for interruption. I have call important call. That's why. Shall we continue? Okay. Now we will see about the GRE, generic routing encapsulation. It's a third method. First method is IP in IP encapsulation. That is first. Means whole header is adding, that new header is adding to our IP header. IP in IP encapsulation. First one is. Second is minimal header with IP packet. This is called minimal encapsulation. That is second method. And the third method is generic routing encapsulation, GRE. Generic routing encapsulation by IP header with IP packet. Now we will see what is happening in the generic routing encapsulation. See, we know IP header in a IP header encapsulation and minimal encapsulation have the drawbacks. We have some drawbacks like in IP header encapsulation and minimal IP header encapsulation. Those drawbacks are routing information for tunneling is not given. Routing information for tunneling means once it's decapsulate and it identifies inside of minimal only, then only it comes to know that information. Otherwise, that new IP address itself don't have routing information for tunneling. There is no tight couple in encapsulation. Can say no recursive encapsulation. Means for continuous packet transmission, for fragments, if fragments are there that are not having the encapsulation, means recursively encapsulation is not happening. That particular fragments we can't do some encapsulation. That is one thing is happening in the IP in IP header encapsulation and minimal header encapsulation. And third thing is here we don't have shared key to use for authentication or encryption purpose. Means with these two things we don't have shared key. If we see in GRE generic routing encapsulation, we have one shared key also for security purpose. Here is providing for security also. Providing security also. We can say if we use generic routing encapsulation with IP header encapsulation, then we can say it's a tight coupled encapsulation. In this way only we can use always for security purpose. Now what is happening, multiple recursive encapsulations are needed when the terminal transmits multiple pieces of packets for the mobile node. See, we are sending IP packets through fragments also. For those fragments also need to apply encapsulation and with security key. That is very important. In GRE, it means generic routing encapsulation, we are doing for each and every fragment that encapsulation also. Each piece of information is encapsulated in one protocol. That is GRE protocol, we can say. Here one or more GRE headers depending on the number of recursive required to send multiple pieces of information. Means we are adding multiple headers to multiple GRE headers to the multiple IP packets with fragments also. Recursively we are encapsulating and we are in a position to forwarding packets to the mobile node. In GRE encapsulation, method 3 components, we will see what are the components present in GRE encapsulation exactly. Means this yellow color in slide is showing it's a GRE encapsulation. Here some flags are there, CRKS, and recursively for sending that recursive flag we have, and here it's representing the version and protocol ID. It's displays and checksum for encountering the errors in transmission of data. That is the purpose we are using a checksum here also. offset value, this is optional value, and key value, here we are using 128-bit key value for security purpose, and sequence number, we are using sequence number also in GRE, and routing, this is optional. Here if we want to add some other flags, we can use in routing place. This is happening. And means in GRE also, like new IP header is first part, and generic routing encapsulation header means new IP header. This pink color is showing new IP header, and this is GRE header, and IP header and IP packet data. This is actual IP header and IP packet data. Here we can say outer header and GRE header original data. This is like this. It's forming the generic routing encapsulation packet. First one is new IP header, and the second is generic routing encapsulation header. Third is our actual header packet with IP header. This is about the generic routing encapsulation. Means here the main advantages we are getting is routing information for tunneling is not given at the time of IP header and IP header in IP header encapsulation or minimal encapsulation. Here routing information is providing. You see, we are able to see routing information. In GRE also clearly we are encapsulation itself, we are able to provide routing information. That is first thing. And for fragments of IP packets also we are applying the encapsulation by using the GRE headers. That is, means we can say for every fragment that recursively encapsulation is happening. That is second advantage. Previously we have discussed like we don't have shared key in IP encapsulation and minimal encapsulation, but here if we see in generic routing encapsulation key, we have key for security purpose also, whether that wrong person is receiving or not, or data or any manipulation of data to check, we have key also. Checksum also, by using checksum also, that error connections we can do, but that means that third person wise we can do this by using this key only. This is happening in the generic routing encapsulation. Now once again, if we see what are the topics up to now we cover, the first thing is tunneling we cover. Means how these tunnels are establishing between source mobile node to home agent to foreign agent to destination mobile node. If corresponding nodes are present in home network and corresponding nodes are present in foreign network, by using those corresponding nodes, how these tunnels are establishing through tunnels, how we are in a position to transmit the data, this kind of stuff we have seen. And reverse tunneling also. Reverse tunneling means from destination mobile node to foreign agent, from foreign agent to home agent to source mobile node. How the reverse tunneling means in bidirectional, how we are in a position to transmit the packets. Then what is the advantage we are getting by using this reverse tunneling? The advantage we are getting by using reverse tunneling is it's a bidirectional, right? It means home agent to foreign agent to home agent. We can multicast the packets to the mobile nodes in home network as well as foreign network. Means as a group we can form one IP address at foreign agent. Through that group IP address we can multicast the packets to the particular mobile node. So like that, same thing in home agent also. Home agent also we can form the one group IP address for multicast IP address, and we can try to send these multicast packets to the particular mobile nodes. So multicasting is one advantage, and second advantage is firewall security. Firewall security is second advantage. In firewall security, what is happening exactly? For every network, we'll have one firewall. Means packets are entering into one particular network is first it to cross the firewall and it enters into the network. Like the same thing, this particular network packets is going to outside the network to enter into the other network, means through firewall only it enables it to enter into the other network. Firewall is in a position to support with the reverse tunneling, means based on those IP addresses, firewall is able to filter the IP packets and it is in a position to transmit those packets to the outside the network and from outside network to the inside network. Means for firewall security also these packets are supporting. Means this tunneling, reverse tunneling mechanism is supporting. And this one we have discussed. And after this we have discussed about the security. If we see security, the main points in security wise, mobile IP uses a strong authentication scheme. Means here this mobile IP standard is using this strong authentication scheme for validating the mobile nodes. All registration messages between a mobile node and home agent to foreign agent, vice versa, are all authentication by verifying authentication only it's happening. Here we are forming the mobile home authentication extension by calculating one code we are forming and we are appending with the actual data and we are trying to send that packet to the receiver. From receiver, whenever it is received, it will try to get the actual data and it is also try to form the mobile home authentication extension and it will equalization with the transmitted mobile home authentication extension. Shortly we call it as a MHAE. And we can say both are equal, that the integrity of the packet always is verifying. Here for security purpose we are using 128-bit key value between anything, mobile node to home agent or home agent to foreign agent to home agent. Like this is happening. And here we have two kinds of authentication extensions: mobile to foreign authentication extension and foreign to home authentication extensions. Means between packets transmitting between mobile to foreign, that's a mobile foreign authentication extension, and foreign to home, who packets are transmitting, means foreign home authentication extension. This is all about the security. And finally we discussed about the encapsulation. If we see once again what are the main points present in the encapsulation. See, we are having the IP header and the actual data. We are forming one more new IP header in the mobile IP networking, that is outer new IP header for the IP packet. Here what we are doing, this new IP header designed for use by networks which enable packet switch data communication. Means this new address, by using this new address between two agents, home agent, foreign agent, we are in a position to transmit the packets. We can do that packets switching between the agents for the data communication. IP provisions, means this new IP header address, it provides the transmission of data packets. Each packet treated independently in IP address. We know that in IP networking, each IP packet we treat as an independent packet only. For every packet, it should have its own IP header. Individual packet only we can see based on the destination address only we are able to transmit the packets. In mobile IP also, that packet size is maximum is 2 power 16 bytes. More than that we can't accommodate. Another IP header, means we can say new IP header is placed over the IP packet. Now the new IP header has the IP address of home agent as the source and IP address of the foreign agent as the destination. Now this home agent address becomes like a source IP address. Now this foreign agent address becomes like a destination IP address. That is in new IP header is forming. New IP header, IP packet header with the IP packet data. This is what hierarchy. There's a new IP header and new data. New data is nothing but a original IP header, and original data is forming the new data. In this inner header present and original data present. This is encapsulation. And the first method we have discussed is IP in IP encapsulation. This is about the IP and IP encapsulation. Here we are able to see source IP addresses as a home agent address, and destination IP address is a foreign agent IP addresses. By decapsulating this particular IP header first, it will try to come to know that mobile node, and it will try to send that particular packet to the finally mobile node. This is one thing we have discussed in IP encapsulation. We know that the data fields present in this are IP version and length of the IP header, precedence of the IP packet, total packet length. To specify the ID for the packet, here packet ID also we are specifying. If it is a fragment offsets we are specifying, and to specify time to leave, type of protocol checksum we are providing here, and IP address of home agent here present, and IP address of foreign agent also present, and if we require IP address of corresponding node, and finally IP address of mobile node. At decapsulation time, foreign agent will identify the mobile node, and it will try to transmit those packets to the mobile node. Means we know that the corresponding node is nothing but a home agent 2 if it is in home network, or foreign agent 2 if it is in foreign network. Finally, the foreign agent reads the IP header encapsulated data to get the care of address. By using the care of address, foreign agent sends packets to the mobile node after decapsulating the new header. Finally, by using the address of mobile node, foreign agent is in a position to transmit those packets to the particular mobile node. That is everything in IP encapsulation. Minimal encapsulation. Minimal encapsulation is nothing but some redundant data we have in the packet transmission, TTL, IHL, version, TOS. We are not going to add these fields in the new IP header. Means we are minimizing the new IP header. That's why we're calling it as a minimal encapsulation. Anyway, it's an option we can use, or we can use also. Without using this one also, we can do the things. This is minimal encapsulation. And the third one is GR, generic routing encapsulation. If we see this new IP header in pink color, this generic routing encapsulation header is happening. Sorry, it's a outer IP header. First one is, and this yellow color is generic routing encapsulation header, and this is our actual IP packet with the header. And we have some drawbacks in IP encapsulation and minimal encapsulation. That's why we are trying to transmitting packets with the generic routing encapsulation. With this encapsulation, we can recursively do that encapsulation with the fragments also. And security wise also, we have shared key here. We don't have shared key provision in first and second methods. So it's a reliable way to transmit the packets. Generic routing encapsulation. In generic routing encapsulation, mainly three components are present: new IP header, generic routing encapsulation header, and IP header and IP packet data. This is all about the generic routing encapsulation. Until now, we have discussed about the IP address importance from last two sessions. With this session, we have discussed like IP address and multiple IP address importance, and mobile IP network layers, packet delivery from home network to foreign network, and handover management while roaming time from home network to foreign network, or foreign network to home network, and location management. Location management is nothing but agent discovery. Agents we have to discover. This mobile node will do that thing. And the registration procedure we have seen, and tunneling, encapsulation. Up to these concepts we have covered. In next session we cover about the route optimization, means how we can optimize the route while packet delivering time between home network to foreign network. That is one concept. Next session we are going to cover. And DHCP protocol, dynamic host control protocol. That one also we will check it. These two things we will check it in next session. Okay. With this, I am concluding this session. Do you have any questions? Please raise the questions. Please ask the questions. Questions. You are able to download the PPT, right?